A 0.10 molar solution of acetic acid is prepared. The acid dissociation constant Ka for this acid is 1.8 times 10 to the negative 5. Calculate the pH of the solution. Assume the solution is at 25 degrees Celsius and that acetic acid only partially ionizes. So acetic acid is a weak acid, and when it comes to weak acid, you cannot calculate their pH directly with the concentration of that weak acid. And that's because they do not dissociate completely or they do not ionize completely. So to start, we're going to write out the dissociation equation. CH3COOH aqueous reacts with H2O to give us H3O plus and CH3COO negative. We're going to do a nice chart, okay? So initially, we had a 0.10 molar concentration of CH3COOH. The concentration of liquids and solids are negligible. So we're going to ignore this H2O liquid, okay? H3O plus was not there at the beginning. Also, the acetate was not there at the beginning, okay? The change in concentration is going to be negative X. We don't know what it is, and since you just have one mole, it's just going to be negative 1X. At equilibrium, you add up the initial and the change, and that is going to give me this. Over here, this is plus X. So the H3O plus and CH3COO negative, they are appearing, and therefore, this will be positive X, positive X. And when 0 adds to X, it just gives us X. So at this point, we're going to write out our Ka expression, which is going to be the product over the reactant concentration, excluding the H2O liquid, okay? So liquid, solid do not appear in the expressions. So our product over the reactant, which is CH3COOH. Now the Ka, the acid dissociation constant given to us is 1.8 times 10 to the negative 5 equals S times X. So at equilibrium, these two are X. S times X is S squared. Okay, this times S over. We're going to ignore this change in concentration because the Ka value given to us is so small compared to the initial concentration. So we can ignore the change. It means that the change in concentration is very small, that it's negligible. So we're just going to say 0.10. Now cross multiply. So after multiplying, S squared will be equal to 1.8 times 10 to the negative 6. To find the X, we're going to do the square root of both sides, okay? So that this will cancel out. After the square root, we'll have X equals 0.00134. And at equilibrium, H3O plus is equal to X, which means that the concentration of H3O plus is equal to 0.00134. pH is equal to negative log of H3O plus, which means that the pH will be equal to negative log of the 0.00134. And that gives me 2.87 as the pH.